Applications of systems of linear equations. A company that manufactures small canoes has a fixed cost of $20,000. It costs $80 to produce each canoe. The selling price is $160 per canoe. In solving this exercise, let X represent the number of canoes produced and sold. Part A asks us to write the cost function. The cost function is given by C of X, and that equals fixed cost plus the cost of the items times the number of items produced. So the problem tells us that we're going to let X represent the number of canoes produced. So our variable is X, and our problem also tells us that the fixed cost is $20,000. So I'll substitute $20,000 for the value of fixed cost. Now the cost per canoe is $80 to produce. So since this is the cost function, this will be 80 times X. So my entire cost function is C of X equals $20,000 plus 80 times X. Now I want to write the revenue function. And the revenue function is given by R of X. And that equals the selling price of the canoe times the number of canoes sold. And again, we're going to use the variable X in this case. And the problem tells us that the selling price is $160. So our revenue function is R of X equals 160 times X. Part C, determine the break-even point. To determine the break-even point, we're going to set the cost function and the revenue function equal to y and then solve the system of equations. Remember, the break-even point tells us that the money coming in is equal to the money going out. So our first step is to set the cost function equal to y and the revenue function equal to y. So now I have two equations in my system. And I'm going to use the substitution method to solve this system. So I'll take y equals 160 times x and plug it in for y in the first equation. Now we need to solve for x. So I'll subtract 80x on both sides. And I'm left with 80x equals 20,000. Next, we'll divide both sides by 80, and we get x equals 250. Now I'm going to take x equals 250 and substitute it in for x in the second equation of y equals 160 times x. So I have y equals 160 times 250, which is 40,000. So my break-even point is 250, 40,000. That tells me that the money coming in equals the money going out when I sell and produce 250 canoes. And then the cost and the revenue of selling and producing 250 canoes is $40,000. The formulas below are the cost and revenue functions for a company that manufactures and sells small radios. Part A, use the formulas shown to write the company's profit function P from producing and selling X radios. The problem gives us the formula or the functions for cost and revenue. The profit is P of X equals R of X minus C of X. So we're going to substitute C of x and R of x into the equation for profit and simplify. So I get P of x equals the revenue, which is 45x, minus the cost, which is 72,000 plus 39x. To simplify this, you need to distribute the negative sign to both terms in parentheses. Next, we're going to combine like terms. I have a 45x and a negative 39x. When I combine those, I get 6x, and then minus the 72,000. So this is as simplified as I can go. So my profit function is P of x equals 6x minus 72,000. Part B. Find the company's profit if 20,000 radios are produced and sold. To solve this, I'm going to take my profit function that I found in Part A and substitute x for 20,000. So I'm going to find the profit of producing and selling 20,000 radios. So this becomes 6 times 20,000 minus 72,000. 6 times 20,000 is 120,000. And then 120,000 minus 72,000 is 48,000. So my profit after selling 20,000 radios is $48,000, and that's my answer to Part B.